So I want to talk about the distinction here between the derivative and the slope. So we know that a slope is just equals to rise over run. So let's talk more concretely about it. So if we're given 2 points, let's say point 1 is, so point 1 is going to be x1 comma y1, and let's say point 2 is going to be, point 2 let's say is x2 and y2. So these are any 2 points in the graph, and we want to find the slope. The slope is just going to be equals to rise over run, which is just y2 minus y1 over x2 minus x1, right? So y2 is the y coordinate of my second point, y1 is the y coordinate of my first point, divided by x2, which is the x coordinate of my second point, minus x1. x1 is the x coordinate of my first point. So that's the idea of a slope. And when we talk about the slope, we usually talk about the slope of a linear equation, or something that looks like a straight line, something that is a straight line. Because usually, and this is not always the case, but usually when we talk about the slope, we're talking about the average rate of change. And we need 2 points to find the slope using this formula that we have here. However, when it comes to talking about the derivative, we're usually referring to the first principles definition of the derivative, which involves the limit, and that and in that we're always talking about the instantaneous rate of change, which means the rate of change at a point in time. Okay, so let's develop that idea a bit more. So on my graph here, I have 2 points. I have the green point and I have the red point. Let me label these points in a peculiar manner. So let's say that my first point, my green point is, so let's say the x coordinate of my green point is going to be a, sorry. So let me use my eraser here. So the x coordinate of my green point is going to be, so yeah, x coordinate is going to be a, and therefore my y coordinate should necessarily be equals to f of a. For my red point, or rather, let me just choose this distance on the x-axis between my red point and my green point. Let me choose this distance to be equals to h. If I do this, then the x coordinate of my red point should just be equals to a plus h, right? So this point, the x coordinate here should just be a plus h, and therefore the y coordinate here should just be f of a plus h, right? So this red point should just be a plus h, comma, f of a plus h, right? That's what this should be. And my green point will just be equals to, this point will just be a, comma, f of a. So now what I want to do is, because I'm interested in finding the slope using 1 point, right? Because I want to find the slope, the instantaneous rate of change, and for that, I just need to find the slope at a point in time. So let me go ahead and use my green point and my red point, and let me plug these 2 points in my slope formula, which I have there in golden, right? So let me go ahead and do that. So let's see. So if I do, I'm gonna get, this is gonna be equals to y2. What is my y2? Let me choose my red point to be my second point and my green point to be my first point. If I choose, so y2 is gonna be equals to f of a plus h, because my red point is my second point, and the y coordinate of that is f of a plus h. So this is gonna be f of a plus h minus y1. y1 is just the y coordinate of my first point. This is just going to be f of a. And I want to divide this by the x coordinate of my second point, which in this case is going to be a plus h, minus the x coordinate of my first point. That's just going to be a. Now let me simplify this. This is just going to be equals to f of a plus h minus f of a divided by h. Now you see, if I want to find the slope of this only at the green point, only at this point, if I want to find the instantaneous rate of change at the green point, what I want to do is I want to reduce this distance here. I want to bring this h as close as I can to 0. The problem is I can't bring this h exactly to 0, because if I do that, this whole expression will become undefined, right? Because division by 0 is something that we don't allow in mathematics, because it breaks the whole framework of mathematics. So mathematicians, they introduced the idea of limit. So what I'm going to do is I'm going to define this, the instantaneous rate of change at the green point. I'm going to define that to be the limit as this distance here, this distance, which is the h, goes to 0 of this expression here. And that is exactly what the derivative is. So let me write that down. So then, in fact, this is not equals to, but the derivative is going to be the limit as h goes to 0 of this expression, which is f of a plus h minus f of a divided by h. So you see, the distinction between the slope and the derivative is that the slope requires 2 points. So slope is rise over run, and it requires 2 points on the graph for us to find the slope, right? Well, however, when it comes to a derivative, it's an idea which involves limits, and it is always the instantaneous rate of change at a point in time, whereas a slope is usually the average rate of change, unless we're talking about the slope of a tangent line. Then in that case, of course, that is also instantaneous rate of change. But the calculus definition of the derivative is exactly what we've derived here, which is the limit as h goes to 0 of f of a plus h minus f of a divided by h. And this definition comes directly from the explanation that we have here, which is the green point and the red point explanation here.